Hi, this is Arash and welcome to the Epoxy channel. In this channel, we're going to talk about the epoxy resins from the theoretical aspects to the most practical ones. So if this is the first video you're watching, or if you're interested in epoxy resins, please like and subscribe to our channel for more videos. Today, I'm going to present other properties of epoxy resins. Almost all tedious documents of epoxy resins have a section which presents visual aspects of the epoxy product. These features sometimes go under the typical properties rubric of the product. Under the appearance section, the color and the physical state of the epoxy resins in hardener and the mix system is presented. It should be noted that here just descriptive statements are presented. For example, if the resin is clear, transparent or hazy, the color which could be pale yellow, reddish, etc., and the physical state which could be liquid, flake, plas, or paste can be presented. Examples are a statement like clear liquid, beige paste, white flakes, etc. There is also another aspect which is important. This is the odor of the product. Here the odor is presented in a subjective manner. For example, with phrases such as slight, pungent, resinous, etc. It might be noted that the appearance, state, or odor are often generic terms and no standards or report method is presented for them. However, the appearance, odor, or state of the product are of great importance, especially from the safety and handling point of view. These have to be presented, by the way, as they are crucial to identify the spilled or leaked materials, for example, in the houseware, especially when the source is not clear. Often the odor of a product is presented in safety data sheet as well. Sometimes the TDS document presents formulation required for a certain applications. This section also can serve as a guide for the customer. Different hardeners, accelerators, and reactive and non-reactive diluents are formulated here, and often the most important property based on the offer system is presented. For example, this property could be the gel time, or it can simply be the viscosity. Often the TDS or SES document epoxy resins have a section entitled Processing. Under this section, different processing-related facts and information can be presented. One of the most important data which is often presented here is the information about mixing. If a certain hardener has been suggested for the epoxy, the mix ratio is presented here as a guide for the customer or the user. There are two ways to report the mix ratios, based on weight or based on volume. If the mix ratio has been presented based on weight fractions, the first digit indicates the amount of the first component in grams, for example, the epoxy resins, and the second digit indicates the corresponding amount of the other component, for example, the hardener. If in the presented example, 100 grams of araldite can be mixed with 38 grams of arador. The same scenario is also valid when the mixing is based on volume. Here we mix 100 cc of araldite with 47 cc of arador, for example, by using a measuring cup. We have also another term known as PHR, which stands for per 100 resin. This indicates the amount of the certain components in 100 grams of the final formulation. Therefore, a mix ratio of 70 PHR means that simply 70 grams of component A has to be mixed with 30 grams of component B. Let's emphasize again that PHR is based on weight and can be presented by the supplier or simply calculated based on the EEW of the resins and the amine weight of the hardener. Other factors that can be presented include the viscosity terms and the application temperature range, which presents the acceptable temperature of the substrate and the environment where the epoxy is supposed to be used. Use temperature range only talks about the ambient temperature. For some products, we also have statements about the moisture. For example, maximum acceptable moisture on the substrate and in the environment. Often epoxy TDS also have a section titled Application Method. Under this title, different types of information can be provided. The main and most common information is about the recommended application of the epoxy resins. In this regard, generic information about the application of the product is presented. For example, an epoxy resins might be recommended for aerospace and industrial composites, tooling, aircraft repair, etc. The second thing that can be presented in the TDS document is the application information. Various aspects of the application of epoxy can be presented under this title. For example, guidelines about the surface preparation, if required, mixing or applying the product can be presented in this section. Sometimes information about the cleaning, the work tools, and equipment maintenance is also presented under this title. Also, any precaution can be reported here when the product is handled or disposed. The information about the curing procedure of an epoxy resin is of great importance for the user. In fact, the user needs specific and solid information about how the resin can be cured properly. Any failure in the curing procedure results in imperfection in delivering the final service. It must be mentioned that the curing procedure depends on the type of the employed hardener, temperature, the presence of other components, for example, catalysts, accelerators, and diluents, and also the post-cure procedure. Also, different users use the epoxy in different situations, at different temperatures, for example, and they use different hardeners and various components in their desired formulation. This information would be really crucial when the customer intends to use the resin in other conditions. In the epoxy resin TDS documents, data regarding the curing of generic systems of epoxy and hardener is presented, which is serve as a guide for the customer. Also, sometimes the time of minimum shear strain at various temperature is reported in different tables. Solid contents. It refers to the amount of base product proportion of non-volatile material left in the adhesives once the volatile solvent has vaporized. This number is expressed as a percentage. Solid content describes the part of liquid that will become solid after it has been applied and had the proper time for hardening. Therefore, 100% solid epoxy resin suggests that coating itself does not contain any water or solvent that could evaporate while curing. It will maintain 100% of its thickness, body and shape after the cure. Their wet film thickness, or WFT, is identical to their dry film thickness, DFT. The liquid in the epoxy will be identical to epoxy that dries whatever you are coating. Advantages of 100% solid epoxy coatings. They have a limited environmental impacts. When solvents evaporate in coating, volatile organic compounds or VOCs get released. That can contribute to air pollution. However, it is less of a problem in low VOC epoxies. In 100% solid, fewer coats are needed. The DFT of low VOC epoxy is the same as or close to these coatings WFT. It means that you need fewer coats to get the same results you would from a high VOC coating. Also a big time saver for your project because the solvent has to be evaporated eventually. 100% solid epoxies have quicker drying times. Though exact drying times vary, some 100% solid epoxy coatings can dry in hours instead of days. Now let's talk about the disadvantages of 100% solid epoxy coatings. 100% solid resins are generally more expensive. It should be noted that applying fewer coats can have financial benefit. Still, the higher cost of high solid coatings might not overweight the reduction in coats. 100% epoxy systems are more difficult to clean up. In the event of overspray, low volatile content epoxy can be harder to clean. Finally, 100% epoxy resins show higher sensitivity to temperature changes. Environments where temperatures fluctuate could cause problems for these types of coatings. Sometimes in the TDS document of epoxy resin, the residual epichlorohydrin is also reported. In the former videos, it has been mentioned that common epoxies are produced by the reaction of bisphenol A and epichlorohydrin. Therefore, it is plausible that traces of unreacted ECH exist in the final product. Epichlorohydrin is a skin sensitizer. In addition, epichlorohydrin is classified as carcinogenic in category 1B, presumed human carcinogen according to the EU classification. In the epoxy resins, prior to curing, generally only a very low amount of residual epichlorohydrin is presented. Manufacturers that are members of European Association Plastic Europe have voluntarily committed to a limit concentration of 0.001% of epichlorohydrin in the resins. However, low-quality resins from outside the European Union might contain significantly higher levels. The other constituent of the epoxy resins monomer is bisphenol A. It is a skin sensitizer too, as well as reproduction toxin class 2 and weakly carcinogenic. It shows effect mimicking those of the female's estrogen hormones. Products that are BPA-free do not contain any trace of bisphenol A. As concerns regarding the safety of BPA and its stability to leach into the food and beverage have grown, many manufacturers have committed to making BPA-free products. Keep in mind, though, that not all BPA-free products are food safe. Hence, to avoid these kinds of health disorders, BPA-free epoxy resins are used nowadays. BPA can be leached out of the epoxy resins by extraction methods using either acidic materials or strong detergents. BPA-free epoxy resins possess different significant properties such as strong adhesion, chemical resistance, strength and toughness, and proper tensile strength, which makes them suitable to be used in manufacturing process of different products. Some industries where BPA-free epoxy resins find major application are paints and coatings, varnishes, adhesives, electronics, and electrical appliances, polymer industries, food and beverages, and automotive. And who manufactures BPA-free epoxies? Olin Corporation, BASF SE, Eastman Chemical Company, AkzoNobel, DuPont, Huntsman are of examples of producers. Flashpoint is another important property which often reported in the TDS or SDS documents. Flashpoint is the lowest temperature at which a liquid will form a vapor in the air near its surface that will flash or briefly ignite on exposure to an open flame. The flashpoint is a general indication of the flammability or combustibility of a liquid. The lower the flashpoint, the more flammability. However, a high flashpoint indicates you have a lower fire hazard when exposed to high temperature heat sources. When operating equipment is at high temperature, a high flashpoint is important first and foremost for operator safety. The flashpoint of the material is one of the required elements on the safety data sheets. Assuming you have a GHS compliant sheet, the flashpoints will be listed in Section 9, Physical and Chemical Properties. It is mandatory. Based on the flashpoints, the products are categorized, and this classification, which is based on safety issues, heavily affects transportation costs. Lower flashpoint products are considered as dangerous goods and will go under certain regulations. Class Class 2 combustible products have a flash point greater than or equal to 100 Fahrenheit, equal to 37.8 centigrade, but less than 140 Fahrenheit, equals to 60 centigrade. Class 3A combustible liquids have a flash point greater than or equal to 114, 60 centigrade, but less than 200 Fahrenheit or 93 centigrades. Epoxy resins are often modified by structural changes, blending with other chemicals, using modifiers or using diluents to improve the certain property in the resins. They are often modified to enhance and maximize a property, for example, electrical, mechanical, adhesiveness, and chemical resistance properties. Epoxies have been modified in a variety of ways for different applications. In paint coatings, the modification includes reacting with fatty acid derived from oil to yield epoxy esters, which were cured the same way as alkyds. Typical ones were L18, 80% linseed, and D4, which means 40% dehydrated castor oil. These are often reacted with styrene to make styronated epoxy esters used as primers. Here, organic chains may be used to hydrophobically modify epoxy resins and change their properties for primer use. There are hundreds of ways that the formulation can be modified. By adding mineral fillers, talc, silica, aluminum, etc. By adding flexibilizers, viscosity reducers, colorants, pigments, thickeners, accelerator, adhesion promoters, and etc. These modifications are made to reduce cost, to improve performance, and to improve processing convenience. As a result, a typical formulator sells various formulations, each tailored to be required of particular application or market. The use of a diluent or reactive diluent to modify the viscosity of an epoxy is a common practice in modifying an epoxy resin's viscosity. Diluents will be presented in a separate video. Unmodified epoxy resin is often called a universal epoxy, derived from the sole reaction of epichlorohydrin and bisphenol A, and no other components or blends are added to that. Volatile organic compounds are compounds that have a high vapor pressure and low water solubility. Many VOCs are human-made chemicals that are used and produced in the manufacture of paints, pharmaceuticals, and refrigerants. VOC typically are industrial solvents such as 3-chloroethylene or fuel oxygenates such as methyl tertiary butyl ether. VOCs are often components of petroleum fuels, hydraulic fluids, paint thinners, and dry cleaning agents. Volatile organic compounds are emitted as gases from certain solids or liquid, including epoxies, during cure. VOC include a variety of chemistries, some of which may have short and long-term adverse health effects. Exposure to VOC vapors can cause a variety of health effects, including eye, nose, and throat irritation, headaches, and loss of coordination, nausea, and damage to the liver, kidneys, or central nervous system. Some VOCs are suspected or proven carcinogens. Concentration of many VOCs are consistently higher indoor, up to 10 times higher than the outdoor. EPA's Total Exposure Assessment Methodology, or TEAM, studies focus levels of about a dozen of common organic pollutants to be 2 to 5 times higher inside homes than outside. Therefore, a product with a lower VOC content is much safer than the one with higher VOC content. All epoxies have a VOC level to some extent. This refers to the volatile organic compounds that make it up. VOCs are what gave epoxy its odor. Concerning epoxies, the VOC source can be the solvent that has been used to modify the viscosity of the resin. Therefore, 100% solid epoxy contains no volatile organic compounds or VOCs. The TDS documents of epoxy resins provide information about the packaging and storage condition as well. Also, information about the handling and safety of epoxy resins products has to be provided in the TDS and SDS documents. For packaging, the producer indicates how the product can be delivered to the customer. For example, for a solid epoxy, 225 kg of tight head drums might have been suggested. For packaging, based on the nature of the product, there are safety regulations. Under the storage and handling section, often the recommended conditions for storing the epoxy system is presented. Other information include the shelf life of the product, hazardous decomposition products, and disposal guidelines. The storage condition is greatly dependent on the type of the product and the temperature range of 2 to 40 centigrade is common recommendation for typical epoxy resins. Hazardous decomposition products are the released component when an epoxy resin is disposed of in a fire. Here again, the type of released product is mainly dependent on the structure of the epoxy resins, but generally speaking, carbon monoxide, carbon dioxide, or other toxic gases and vapors are common when the epoxy resin is put on fire. Under the disposal sections, guidelines for the safe disposal of the cured and uncured epoxies are presented. Often, the TDS SDS documents refer the user to the regular procedures approved by the local authorities. Finally, under the safe handling section, safety recommendations and guidelines are presented for the workers, for example, the use of PPE, etc. Generally speaking, mandatory and recommended industrial hygiene procedures should be followed whenever epoxy products are being handled and processed. Detailed information can be found in the CS document, which has to be provided with epoxy documents. Thanks for your attention. I hope you found this video interesting. Please share your thoughts, comments, and questions, and I will come back to you soon.